Hello everyone, welcome to the course on Foundation and Substructure Construction. I am Xu Yi, the lecturer of this section. Through the last lesson, we have a preliminary understanding of earthwork excavation engineering in excavation. However, most of architectural engineering projects in Guizhou province are built on mountain slopes, which puts forward many requirements for the earthwork leveling of our early construction site. Let's think about it. There is a lot of earthwork excavation in the early stage of site leveling. How to determine the volume of earthwork excavation? With this question in mind, we enter today's class, earthwork volume calculation through grid method. The main tasks of this section include three aspects. First, understand the definition of grid method. Second, master the calculation method of grid method. Third, master the use of grid method proficiently. Solve the calculation of earthwork volume of the site. Let's take a look at the definition of the grid method first. Because the shape of earthwork is often complex and irregular, it is difficult to obtain accurate calculation results of earthwork volume. Generally, it can be divided into certain geometric shapes. According to the grid, adopt the calculation method with certain accuracy and close to the actual situation. This method is suitable for sections with gentle terrain or large step width. The calculation of this method is complicated but has high accuracy. Next, let's look at the calculation steps of the grid method. Division of the first grid. According to the existing topographic map, generally the 1 to 500 topographic map, the site to be calculated is divided into several square grids, which correspond to the measured vertical and horizontal coordinates as much as possible. The square grids are generally 20 meters by 20 meters or 40 meters by 40 meters. The corresponding design elevation and natural elevation are marked on the lower right and the lower left corners of the square grids respectively, and the height difference between the design elevation and the natural ground elevation is marked on the upper right corner. And for the construction height of each corner, the cut is negative and the fill is negative. As shown in the formula, Hn minus Hn equals to H0. H0 is the cut and fill height of construction. Hn is the design elevation of the intersection, and Hn is the natural elevation of the intersection. Second, determine the zero position. When there are fill and cut in a grid at the same time, the 0 point position on the edge line of the grid should be calculated first, and the 0 point connecting each point should be marked on the grid. That is, obtain the boundary between the fill area and the cut area, which is the zero line. The position of the vertex is calculated according to the following formula. Vertex position x n equals to h1 divided by h1 plus h2 times a. x2 equals to h2 divided by h1 plus h2 times a. x1 and x2 in the formula represent the distance from the corner point to the 0 point. h1 and h2 mean the construction height of two adjacent corner points. The construction height here is expressed in absolute value, and A is the side length of the grid in the square grid. The third is to calculate the engineering volume of the square grid. Calculate the volume of cut and fill in each grid according to the bottom graph of the grid and the volume formula shown in the table below. For the item 1, the situation of one-point fill or one-point cut is shown in the figure. Assuming that point 1, point 2, and point 4 are cut, the corresponding construction height can be determined by calculation that the 3 points H1, H2, and H4 are fill. The construction height of the fill is H3. There are 0 points on side 1 and 3 and side 3 and 4 of the corresponding grid with cut and fill. Through the 0-point determination method, the length of the 0 points away from 3 points is determined to be C and B respectively. Connecting the 0 points forms the 0 line. Correspondingly, the shaded area, i.e., the triangular area is the fill area, and the unshaded pentagonal area is the cut area. Then calculate the fill engineering volume. Through the formula V equals to 16BC times H3. Here, let's look at item 3. It's easy to find the situation of 3-point fill or cut. This is the situation where point 1, point 2, and point 4 are cut. That is, the engineering volume in the pentagonal area is the cut volume. Refer to the corresponding formula. V equals a square minus 1/2 BC times by open parentheses H1 plus H2 plus H4 divided by 5 to calculate, and the engineering volume in the cut area can be obtained. Next, the situations of 2-point cut, 2-point fill, 4-point fill, and 4-point cut will not be repeated here. You can make calculations according to the method just mentioned, combined with our legends and formulas. Through today's study, we have preliminarily mastered the method of calculating the earthwork volume by grid method. That's all for today's lesson. I hope everyone can learn something. Thank you.